Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by Datadog. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of housekeeping notes I'd like to review with you. First of all, we are recording today's session. So if you miss any of our conversation, if you'd like to rewatch at a later time, or if you'd like to share with your team, you will be receiving an email with a link to access this recording on demand. You'll be receiving that email shortly after we conclude this live session today. Now, if you'd like to be part of our session, there are a couple of ways to do so. The first way to communicate with us is through the chat tab on the right side of your screen. So when you find that chat tab, I'd like you to let the rest of our audience know from where in the world you're joining us today. If you have any specific questions, we do really want you to submit those questions to the Q&A tab on the right side of the screen as well. We'll be holding most questions until the end, but we do have time set aside to address your questions. So be sure to send them in and we'll be sure to tack them on at the end. So if you jump over to the handout section as well, you'll see there is a resource called Handout Sheet. And if you download that PDF, it is actually just going to be all of the resources that were available for today's call. So feel free to just grab that one handout. And I will also announce that we will be selecting two $50 Amazon gift card winners based on those who engaged with us the most today, either filling out our survey, sending in questions, chats, all of them make you eligible. So our topic today is unraveling threats in the cloud, leveraging telemetry for effective detection in Google Cloud Platform. I'm joined today by Day Johnson, Product Detection Engineer at Datadog, Martin McCloskey, Senior Detection Engineer at Datadog, and Kambiz Kazemi, Staff Solutions Engineer at Google. So Day, Martin, and Kambiz, thank you all so much for joining us today on Techstrong Learning. Day, would you like to take us into the rest of our slides?
Yes, most definitely. Thanks for the introduction there. Hey everyone, my name is Day and I'm a detection engineer at Datadog. Today we're going to be starting off this presentation by giving you an idea into some threats within Google Cloud as well as how you can leverage the telemetry from Google Cloud to actually identify these threats. So let's just get right into it. All right, so like I said, our agenda is just looking at threat detection in Google Cloud as well as a Google Cloud security overview. So let's start by actually going over like detection modeling. How did we approach, looking at how we can build out these detections using the available telemetry that exists within Google Cloud? So when we were doing our research into these different detections, we categorized them into two different categories. The first one being the knowns, and the other one being the unknowns. So I'll actually be going over the knowns in this presentation, and later on in this presentation, Martin will be taking over the unknowns and going into those different things we can look at in that direction. But in regards to the knowns, we incorporated various community-derived research and threat hunting methodologies into our methods and our processes to develop these threat detections for Google Cloud. And these knowns are the things that are known to have been used in the wild. So it could be everything from behaviors, toolings, and threat indicators that we've been able to connect back to threat actors or their campaigns or their malware. And with these detections that we're going to go over for these different nodes, we can have a higher degree of confidence that we'll be able to actually catch attacker behavior within Google Cloud environments. All right, so this is an example of a possible attack path within a Google Cloud environment. So you can see here we have the attacker very right there on the very far left, and these are different paths that can take into compromising different resources that might exist within your Google Cloud environment. Now, bear in mind an infinite amount. There's an infinite permutation of possibilities as to how an attacker might compromise a Google Cloud environment, but we're only highlighting a couple of the most common ones and the ones that you might want to pay attention to. But definitely keep in mind that there are other possibilities here. But let's go over these ones that a little bit more important and the ones that we've actually seen being executed in the wild. All right, so again with the nodes. The very first one we're going over is the default service account usage outside of Google Cloud. Now let's prime ourselves quickly about Google Cloud Service accounts. So these are, default from Google. These are the default service accounts that Google provides. They're typically used by resources or applications rather than users, which is why they are service accounts. They're supposed to perform different actions on behalf of the user within your Google Cloud environment. And they currently exist for the App Engine and the Google Compute Engine. So, they're just cool service accounts, but with these service accounts, there are some inherent risks that exist, right? So some of these things, the first one I want to highlight is the usage of this service account outside of Google Cloud's IP address range, and this could easily suggest that the service account has been compromised. So since we've initially primed ourselves knowing that these service accounts are typically used by resources, within Google Cloud, and we see these service accounts authenticating from, outside of Google Cloud, we could have some level of confidence that this is a possibility of, actual compromise from this service account. Another thing with this service account is the fact that sometimes they're highly permissive, meaning that, they could pose a significant danger if they exploited. So they have the ability to perform various things, and this is specifically for the default service accounts. Now, knowing this, in regards to the permissive nature of this service accounts, currently with the editor role, there's about 7,000 permissions that this service account actually has, and that's just because of the editor role, which is one of the default roles that Google Cloud has. So how do we actually detect, the usage of this service accounts from outside of Google Cloud? The very first query here is going to be a way by which you can do this, and this is a based off of this. You can easily actually use these queries based on the Google Cloud Log Explorer. So you can either convert these queries into whatever detection methodology you might have, but just for ease of understanding and ease of usability, you can just actually plug in these queries into your Google Cloud Log Explorer and look for activities that might fit into this category. But we're essentially looking for when there's a activity from the compute service account or the apps, the compute engine service account or the app engine service account, and when that activity is not coming from the compute engine or an app engine. And also bear in mind that this possibility, of course, it might seem malicious, but there's also legitimate use cases or possibilities where these service accounts are legitimately being used from outside of a Google Cloud environment. So you might want to look into different ways by which you can suppress specific IP address ranges or even Google Cloud's IP address ranges to increase the fidelity of this activity if it's actually malicious. And you can also look into ways to enrich it. So you could use different indicators such as if that activity is occurring from a Tor IP address or a VPN or an anonymizer or from another cloud environment that you don't expect to see activity from within your Google Cloud environment. The goal here is just to look for, what is malicious in terms of a Google Cloud Service account authenticating or performing activities within your Google Cloud environment, but having the activity originating from outside of your Google Cloud environment. Now, moving on to another detection that we're going to go over is the service account key creation, and this is sort of in the same story behind the usage of a default service account outside of Google Cloud. So with service account key creation, we can tie this back into the Google Cloud service account being used outside of Google Cloud. Typically, if an attacker is able to gain access to that service account key, they can then use it outside of Google Cloud. So these two kind of tie into each other, which is why they follow after one another. So with the service account key creation, this is something that's pretty ubiquitous across all major cloud providers. You probably hear this with other major cloud providers are familiar with when a key or an access key is compromised. So this is no different when it comes to Google Cloud. So in this sense, like with the service account key creation, essentially you can use this as a means of persistence within a Google Cloud project. And this activity has been recorded by several security researchers. Now, the thing here with the service account keys is like when they're created, they're sort of immortal by nature. They actually never expire. As you can see here, when you create a service account key, they stay until a very long time. And this is, of course, to make sure like you can use the service account for as long as possible. But with that comes some inherent security risk. And you can see here from that date, from June 10th to that date, you can see it's like almost 8,000 years, and that's quite a long time. So with service account key creation, you can also use some native Google Cloud configurations to actually limit the possibility of this activity. So Google Cloud actually gives you the ability to create some more short-lived credentials in a way that you can actually allow your service accounts to function properly without having them to be immortal. And you also have the ability to limit the lifetime of your service accounts. So even though they might be immortal, quote unquote, by default, you have the ability to limit how long they actually exist by setting an expiry time for these service accounts. So this is sort of a preventative measure before actually going into a detective measure. But going into a detective measure, if you do want to look into how you can detect or identify when a service account key is being created within your Google Cloud environment, you're essentially looking for the method name of the create service account within your Google Cloud environment. This is essentially an API call that someone would make if they're to create a service account key within your Google Cloud environment. Now, of course, again, with various detections, there's a certain amount of noise or false positives that might come, and this might come from actual service account legitimate service account key creation, right? So you have to bear that in mind that some people might be legitimately creating service account with service account keys within your Google Cloud environment, and that's something you want to factor in when you're putting out this detection. And on the other end, if you actually do avoid service account key creation and just use the IAM credentials API to broker short-lived credentials, then you have a higher level of confidence that it is malicious when you actually see service account key creation. So that is if you're putting in a preventative measure of using short-lived credentials, and you'd actually see something going against that measure in terms of creating a service account key when you have that measure in place, then you have a high level of confidence that this is actually malicious activity. And then in terms of enrichment, making sure like this actually surfaces malicious activity with a lot more confidence. You can look into enriching the activity with no looking out if it's activity from a Tor IP address or VPN or an anonymizer or any IP address that is not expected to be creating service account keys within your environment. Another way is also looking for unfamiliar ASNs, and another one too is also looking at dormant service accounts. Now this is very subjective within the context of your Google Cloud environment. A dormant service account within your Google Cloud environment could be 7 days, could be 30 days. So knowing what dormant looks like within your Google Cloud environment, and then looking at when someone is creating a service account key for that dormant service account within your Google Cloud environment could also add a level of confidence into determining, if this is actual malicious activity within your Google Cloud environment. The next one we're going to be looking at is the creation of an egress firewall rule. Now, this is also pretty ubiquitous amongst other cloud providers in terms of crypto mining activity. So this is when an egress firewall rule is being opened up to the world, and it typically facilitates crypto mining for attackers when they're trying to compromise compute instances or compute engine instances in this case for Google Cloud. This typically occurs when a compute engine instance is created within Google Cloud, and a similar tactic is also used with the creating a compute engine network. The goal essentially is to allow traffic to be able to move out of the cloud environment. This could either be done for crypto mining or even exfiltration activity. Now going straight into the detection of this, you're looking for when the compute firewall insert API call is made, and then the direction is egress because you're looking for when it's an egress rule, and then the destination range is going to be a 0.0.0 destination IP range, meaning all IP address ranges. Now you could possibly even look for specific IP address ranges, but the attacker is more likely to have that all IP address ranges just for ease of use for their malicious activities. Again, with this, you could expect actual legitimate firewall egress rule creation. So you also have to balance this between, what actually looks normal and what is actually malicious, and also factor in the possibilities of insider threats as well. So not every single time would it be like an external threat actor. Some people might have access within your Google Cloud environment who are actually legitimate employees, and they're able to perform this activity. So being able to weigh the balance between what is a true positive and what is a false positive, and looking for that activity. And then in terms of enrichment, and again here, you could look for specific activities from Tor IP addresses or VPNs or anonymizers, again with unfamiliar ASNs. Another one to specifically look out for is the attacker would want to create a firewall rule that is similar to the default firewall rule. So they would use very, very similar naming conventions. I believe it's a typo squatted methodology as to using very similar naming similar naming conventions to what default looks like. So you can see like default one, or replacing the L with a one, and just making it look very similar to what your own naming conventions look like within your cloud environments. So that's something to look out for with the firewall egress rule creation, and also with any other thing within your environment. If there's something that's similar to what your naming conventions look like, but it's not the same, then that's a possibility of something, not being legitimate or being malicious within the Google Cloud environment. And I'm going to pass it on to Martin to continue on with the unknowns we did as part of our research.
Cool. Thank you very much, Dave. I will take over from here. So just a quick recap on the unknowns. These are techniques that are likely or possibly seen in the wild, generally reported via red team engagements or security researchers. So first off, we're going to look at a persistence technique. So it is the addition of an external principal as a Google Cloud project owner. So this technique was first recorded by Brad Richardson and Madhav Bhatt at B-Sides San Francisco 2022. So one of the features of Google Cloud IAM is that a project can be accessed by a Google account. So a Google account represents a developer, an administrator, or any person that interacts with Google Cloud. So any email associated with a Google account can be an identity, including a gmail.com domain or other domains. Now, an attacker can exploit this feature to add an account that they control to a victim's Google Cloud project as an owner. So we're just going to look quickly at what this would look like. So in this example, we're showing our attacker adding a Gmail address to this Google Cloud project. I should specify it's not limited to just Google mail addresses. It could just be any domain that's been registered under a Google account. Now, let's look at how we could actually detect this. Now, at a high level, we are looking for the API call insert project ownership invite. This call should be relatively rare, so there shouldn't be too much of a high volume. And then in addition to this, you're looking for a domain that's not part of your organization. In this example, we're looking at Gmail, but you should work with your DevOps teams or platform teams to understand what other domains your company owns to exclude those. You may see some false positives or noise. Maybe developers are testing and they will add personal accounts. This is something we've seen, and it is something to look out for. And again, with enrichment, you can see a theme for Google Cloud Logs. IP enrichment is very helpful. So possibly any anonymization software may be of interest to give you a higher confidence signal, unfamiliar ASNs, and then we've already touched on the domains outside of your organization. And then the second technique we're going to look at is another persistence one, but also could be used as a lateral movement technique. So it's the addition or modification of SSH keys for the GCP project metadata. You can add a public SSH key to compute project metadata to access all VMs in a project except those that block project-wide SSH keys. So an attacker already has initial access to your project, may try to preserve that access or laterally move to other instances by adding their SSH key to the compute project metadata, which you can see in the screenshot. So detecting this, again, initially we look for the specific API call, the set common instance metadata, and then we're looking for the SSH keys being modified or added. So this is a benign activity in general. So you may see some false positives, again, especially if this is a common practice within your organization. In general, it's actually recommended to use OS login instead of SSH keys. This is a Google Cloud recommendation, and we'll talk about this in a couple of slides. But if this feature is implemented, you'll naturally see a reduction in this type of activity, and therefore, if it is to occur, will be of interest. Again, the enrichment here, very similar that you could choose IP enrichments, unfamiliar network metadata like ASNs. So just to touch a little on OS login. So this is a feature that lets you use compute engine IAM roles to manage SSH access to Linux instances. We can see there in the metadata the key value pair of enable-os login set to true, and that sets it to true for all the instances in your project. So OS login simplifies SSH management by linking your Linux user account to your Google identity. Then lastly, we're going to touch on an exfiltration technique via Google Cloud BigQuery. So BigQuery is Google Cloud's fully managed data warehouse. It's used by a lot of organizations to store a lot of sensitive data, and therefore it's a really good target for most attackers. So we're just going to look specifically at BigQuery's export function to cloud storage. So an attacker with the correct permissions can export this table data to a Google Cloud storage bucket in a project that they own, an AWS S3 bucket, or even Azure Blob Storage. Now looking at the detection for this, so we're looking for the job service insert job API call. The job config type will be export, and then a destination URI with a cloud storage prefix. So you will, if your company is or organization is making use of BigQuery, there's likely going to be some noise associated with this type of detection. My recommendation here is that you'll likely see it with Google Cloud Storage, and what you can do is use a lookup table or some type of reference table to filter out cloud storage buckets that your organization owns. By doing that, you should be left with whatever type of signal fires then should be relatively interesting to you. And again, exports to other cloud environments like AWS or Azure should probably be quite interesting, especially if you don't do it. And then IP enrichment, again, can be super helpful for filtering out some noise. So I'm just going to bring it all together at this point with two very succinct points. As you can tell, context helps a lot when it comes to cloud threat detection. And secondly, secure configurations enable higher confidence detections. I think you could take that away in the OS login section and the cloud IAM credential broker. I think the next slide is just our sources and references, so you can check them at the end if you'd like, and I will pass this over to Kambiz.
Thank you, Martin. So let's start with talking about what security means inside Google Cloud and how we can accomplish the goal of security. So what is our philosophy when it comes to securing your applications in the cloud? It's very simple. You have to secure everything every time you can. So if you look at this chart, basically starting from the top side, first of all, we have your internet-facing applications, right? These are the stuff that your customers will, or your clients will access over the internet. So here you definitely want to use things like GCLB, which is our layer 7 global load balancer that can do TLS inspections as well. And it does have some DDoS detection and prevention capabilities at the edge. We can use Cloud Armor, which is our layer 7 WAF technology, and you can use customized rule sets. You have to look at telemetry. You have to preferably use TLS everywhere you can, identity-aware proxy, and also we focus a lot on partner solutions. So there are third-party security solutions that you can use in this case, and pretty much in every domain of security. Second one. Now let's move inside Google Cloud. Now we are talking about communication that happens between your VPCs, or communication that happens to your on-prem location or branch offices, or communication that happens between the VPCs and API services. If you pretty much look at the portfolio of what we offer as GCP services, they either happen to be inside of a VPC, so that's going to be your constraint, or they are some sort of an API-based service, such as BigQuery or GCS. So how do we secure the communication between these services? First and foremost, we use VPC firewall rules. Of course, these are layer 3, layer 4 firewall rules. They do not have application understanding. They can use basically with ports and protocols and IP addresses and service accounts and all of that good stuff, but they do not have understanding of layer 7 applications, right? So meaning that if web traffic is allowed, they cannot detect if an exploit is passed through a web request. And for this specific purpose, I will later talk about a new technology and a new solution that we have, which is our first-party layer 7 firewall solution. We will talk about it in much more details. But basically, your first point of defense is leveraging the VPC firewalls. The second one is something that is extremely important, and I see some customers paying enough attention to it, and some customers less deploy it. Basically, VPC service controls is a way for you, and I will talk about this in the next slide as well, but is a way for you to create a perimeter around what you consider to be secure and trusted versus unsecure. And then you control the flow of traffic from untrust to trust and also within trust. So that's a very powerful tool that we can also use. Telemetry is always important. For external communication, of course, for everything that happens to be outbound traffic, we suggest using Cloud NAT because you are using an SDN service and you're hiding your IP address and all of that good stuff. So that's definitely best practice. And of course, VPNs and interconnects. Interconnects are secure and private by nature, and VPNs basically use encryption. Also leveraging partner solutions. Now, let's go inside of a VPC. So inside of a VPC, when it comes to GCE and GKE services, they talked a lot about the IAM policies and IAM best practices and governance aspects. All of that stuff should be there. That's a must. Basically, the least privileged principle always should apply. GKE network policies, that's another extremely powerful tool that you can use. Telemetry. Try into getting the habit of creating your firewall rules by service account and not just by IP addresses or GC instances. Try to use hardened images and also use partner solutions. Like, for example, if you're talking GKE, yes, Google has a full set of solutions for securing GKE, but we also have a lot of partner solutions for securing GKE, either in build time, shift time, or runtime. So try to use them basically to maximize your security. And on top of all of these, there are, of course, 3 important first-party Google security tools that we always have to pay attention to. On the left side, you see BeyondCorp. That's for basically zero trust and secure access to Google Cloud. We have the Security Command Center, which is our CSPM/CNAP platform. And basically, it can help you with things like gathering telemetry and threat detection and all of that stuff, and giving you reports on compliance and your security posture. And also Chronicle. We talked about a lot about the importance of threat detection, prevention, data exfiltration, and all of that stuff. So Chronicle is basically our SIEM or advanced SIEM that can do all of that for you. Basically provide threat detection. It has its own query language. We are actually enhancing it by leveraging AI now. The very cool thing right now is that you can write your queries in human language, and basically it will translate it to the Chronicle specific query language. So secure everywhere you can. Think about your application that are internet facing. Think about communication between VPCs to on-prem and to API-based services. Think about microsegmentation and securing your traffic inside of a VPC. Also, have in mind zero trust secure access, having the right CSPM CNAP platform, and also the right threat detection and vulnerability detection tool. Let's go to the next one. So this is where I wanted to talk about the overall approach to securing services inside Google Cloud. So what do I have here? In the middle, I have a VPC. And inside that VPC, let's say I have a GCE application, I have a GKE service, Under that, I have the API-based services. Let's say in this case, I have GCS, I have BigQuery, or any other API-based services. Left side is internet, and right side is your on-premises location. So let's talk about how we secure all flows of traffic. So traffic coming in from internet. Your first point of defense is the GCLB, which is our layer 7 load balancer, and Cloud Armor. So basically, you filter out all the DDoS attacks, all the web vulnerabilities, all of that stuff by leveraging our layer 7 load balancer and our advanced WAF, which is Cloud Armor. Then as you come into the VPC, you obviously have the VPC firewall rules. Inside the VPC, let's say your GCVM or application wants to talk to a service or pod on your GKE cluster. Again, you can leverage the VPC firewalls. Again, these are layer 4. I will talk about layer 7 in a minute. Also, we have packet mirroring. If you need to basically inspect every single packet that is traversing for testing purposes or for threat detection, we have that capability natively available. Now, on top of this, let's talk about VPC service controls. As you can see here, I can create a perimeter. I can say, well, my perimeter consists of my GKE service inside this VPC, my applications, and also 2 of my API-based services, BigQuery and GCS. I'm going to create a perimeter around this. And then I can say for access from outside to these types of services, I will enforce certain policies. Like, for example, users only can access my GC application if they connect from this range of IP address or from this country or at this time of the day. So, and it's context aware. Or I can say, well, let's go to my GCE, but not every application on GCE is allowed to use, let's say, BigQuery. So again, we talked about these lateral movements, right? This VPC service control is a very efficient way to control these lateral movements. If for whatever reason the internal bad actor or the external attacker has a foothold in your application or inside your GKE, this is one of the ways that we can basically monitor and track and block that lateral movement. And same thing applies to on-prem. You can basically say, well, which on-prem location can access, how they can access, what is the specific policy that they have to access. Also on the right side, you can see interconnect and VPN. Again, these are basically solutions for secure private connectivity back to your on-prem location or to your basically branch offices. So use all of these tools effectively. I think I emphasized enough on the importance of leveraging layer 7 load balancer, Cloud Armor, IAP, identity aware proxy, most importantly, VPC service controls, leveraging interconnects and VPN whenever you can, and trying to basically stop the lateral movement of attacks and exploits inside your environment. Let's go to the next slide. So we talked a lot about detecting threats, basically threat detection, threat hunting, and also preventing data exfiltration. Now, traditionally, we have always had our GCP firewall rules, which are layer 3, layer 4. As I can say, they are your basic and first line of defense, but they were not enough because they don't have the layer 7 application understanding. They do not have an IPS. They do not understand layer 7 threats. They do not understand exploits. They don't have URL filtering capabilities or do a TLS offload and a lot of other stuff. So for that very reason, a lot of our customers tend to use a third-party solution, basically a third-party next-generation firewall solution from the major firewall vendors that you all know. Now, what we have done with Cloud Firewall Plus, and Cloud Firewall Plus actually has basically an ancestor, which is Cloud IDS. So last year, we introduced Cloud IDS, which is a first-party Cloud IDS service. Basically, instead of going and deploying a third-party solution for your Cloud IDS that could be deployed for threat detection, or it could be used for basically your compliance requirements, now you can basically do everything as a first-party service. So everything happens inside Google Cloud's console. And by a couple of nexts and deploys, basically you have your service fully up and running. Now, we have repeated the same exercise and come up with a solution that is called Cloud Firewall Plus. And the other two major CSPs also have a competitive platform. One other key aspect that Cloud Firewall Plus has, and I will talk about why it has that, is ability to do microsegmentation even inside your VPC. So traditionally, when we had a VPC and traffic was moving from one subnet to the other subnets, there was no way for us to override the VPC basically most specific route and say, well, go to this next generation firewall, get inspected, and come back. We could never do that, right? Or even within the same subnet, of course, we couldn't do that. So we could only inspect the traffic going between VPCs. Now, leveraging Cloud Firewall Plus, we can also inspect traffic inside of the VPC, regardless of it's going from a subnet to another subnet, or even the same subnet, or even if the traffic is going, let's say, from your GCE or GKE going back to your API-based services. So basically with this, I can have full control over traffic that is initiated from a Kubernetes pod going to BigQuery or going to GCS. That is fully available now. It's in public preview, by the way. It's not GA yet. But these are the different tiers of our cloud firewall that basically you guys know the cloud firewall essentials. That's the traditional way of layer 3, layer 4 inspection that we have done. What I am going to talk about here is the Cloud Firewall Plus, which is the furthest right column. Basically, as you can see, it has all the previous features, as well as advanced threat intelligence, intrusion prevention system capabilities. It understands FQDN. It can block the DNS attacks. It can block command and control channels. You can create geolocation objects. And one of the most important aspects is that you can do TLS decryption with it. Basically, encrypted traffic to a next generation firewall degrades the value of your firewall because your firewall cannot see the actual payload. So Cloud Firewall Plus basically provides a way for you to natively decrypt the traffic as it traverses the Cloud Firewall Plus, look at the payload, inspect it for everything that you want, for malware, for exploits, or anything you want, re-encrypt it, and put it back on the wire and let it continue to its destination. And one more thing to add here is the macro-segmentation capability that I talked about. So now you can basically secure traffic within the VPC as well. Now, let's take a look at how it works. Basically, before getting to that, I wanted to talk about, I pretty much covered this, but we were looking for a first-party solution that gives you full visibility and control on your traffic, whether being encrypted or unencrypted. We wanted to make sure that it can cover both north-south traffic as well as east-west traffic and cover macro-segmentation. We were looking for something that is easy to deploy and manage. So this was a key aspect. Leveraging third-party solutions and firewall vendors is always a choice, but deploying it in reality takes a lot of cycles and a lot of resources in terms of the design and implementation, because it usually requires some level of design for high availability and basically things like complex routing or NATing, and basically creating all of those policies on those third-party firewall platforms. We have taken all of that away. So you technically can go to the Google Cloud Console, click a couple of next, and then within a few minutes, you will have your setup ready. And we also wanted to have no compromise on the security efficacy. Basically, we wanted to go from the layer 3, layer 4 basic firewalls to an advanced next-generation firewall. So let's take a look at how it works. Left side is the customer's VPC. And as you can see, or the customer's environment. So I have a VPC. Inside that, I have a bunch of GCE VMs. I might have a GK cluster. Customer is also using the API-based services, again, such as BigQuery, SQL, GCS, or any other API-based services that they have. We have hundreds of those. We do have connectivity to on-prem and internet. And here's my goal. I want all traffic, regardless of where it comes or where it goes, to be fully inspected at layer 7 with decryption. So traffic could be coming from the internet, could be encrypted. I want to inspect it. Traffic could be going from my VPC to the internet. I want to inspect it. Same thing for on-prem. Or traffic could be going from my GCE application to one of my API-based services. I want to be able to inspect it. So how do I do that? And I want to do it in an easy way, a first-party solution. So what we have done under the hood is that we created a new technology called Packet Intercept. So what Packet Intercept does, imagine this scenario. Imagine your GCE virtual machine wants to connect to your GCS. So the first packet comes to the NIC. Now, the NIC of the VM. Now, what we do with the Packet Intercept is we hijack that packet at the NIC level. We take it to the middle box. And that is where Cloud Firewall Plus is deployed. So Cloud Firewall Plus is deployed outside of the customer's project. So what we do is we hijack that at the virtual NIC level. We bring it to Cloud Firewall Plus, which is basically a stack of next generation firewalls with a load balancer. So it has high availability and everything that you want, and it scales out. We look at the policy. If we need to decrypt it, we will decrypt it. We will inspect it for malware, for exploits, for DNS exploits, for command and control channel, and everything that the next generation firewall is supposed to do. Then if we need, we will re-encrypt it, and we will return it back to the original virtual NIC. Now the packet continues its regular routing path. So this is a very easy, seamless way to integrate an advanced firewall into your traffic. So you are not making any routing changes. Basically, you are not even going to your VPC and creating a route or a NAT policy, nothing. All you have to do is to declare your intention through the Cloud Firewall Plus policy, and we will take care of everything for you. So long story short, as the packet wants to leave your GCE VM, we will hijack it through Packet Intercept, and you have declared that intention. You have said, for example, all traffic that is going from this GCE VM to, let's say, another VM and is web traffic, I want it to be inspected. So we hijack the packet at the virtual NIC, we take it to the middle side, we inspect it, decrypt it if needed, put it back together, bring it back to the original virtual NIC, and then let the packet continue its regular routing route. So that's how we do it. Out of the box, Cloud Firewall Plus has integration. Of course, it has a UI. You can access it through the API as well. It has out-of-the-box integration with Cloud Logging, with Security Command Center, and with Chronicle. So this is a high-level overview of how it works. The most important thing that you need to know is it's a highly available firewall, highly scale-out model, and then we do everything under the hood for you. And for that, we use a technology called Packet Intercept. Let's go to the next slide and walk through how we deploy this. So imagine if you wanted to deploy this yourself, you had to go through a 2 weeks, 1 month, 3 months practice of design and consultation and deployment to deploy those next generation firewalls. And you had to take care of everything, including scale out and basically complex routing and NATing and changing your VPC routes and basically inserting those firewalls. Now, let's say how we can do this. All you have to do is these steps. You create a threat prevention security profile. Basically, you specify what you want to do with the traffic. You create a security firewall group, which is basically just a container of the security profiles. And you can basically add and delete those. So just think of them as a container for your security profiles. Next step, you actually create the IPS endpoint. So here's where you are going to the firewall manager and saying, well, go ahead and create those firewalls for me. And of course, it will create a load balancer for you as well, an ILB. Next step, you attach it to the VPC. And then lastly, you just sit there, wait for it to get deployed. Usually takes around 10 minutes, and you can view the threats inside the firewall manager without going to another third-party console. So let's take a look at some of the screenshots here. This is a screenshot of creating your IPS security profile. Here I'm saying, well, create a profile for me, which is doing either threat prevention or URL filtering. In this case, I'm choosing threat prevention. So detect all of the malware, all of the exploits, all of the vulnerabilities for me. And here I am specifying my intention. I'm saying for anything, let's say there's an exploit that has a security or severity level of critical. I want to deny it. But if it's high, I want to just log on it. So I declare my intention. I'm going to say for web traffic, if it's critical, block it, deny it, and of course, log it. If it's high or medium, or you could do the same thing for high. You can say for high, also block it. And for medium and anything lower than medium, just log it. Don't block it, but just log it for me. So I'm declaring my intention. Next, I go ahead and create that group. So as I just mentioned before, it's just a container for putting those security profiles together. Now, you create your IPS endpoint. And by the way, something I forgot to mention, it's under the network security tab here, right? So basically, as you know, inside Google Cloud Console, you have a network security tab and you have a bunch of services here. You have Cloud Armor, you have Cloud IDS, and a bunch of other services. So Cloud Firewall Plus is just a new tab that we have added. So here you go under the Firewall Manager and you say, well, create that IPS endpoint for me. This is the piece that actually takes time because under the hood, we are creating that packet intercept tunnel, which uses the Geneva encapsulation. Also, we are creating that stack of firewall for you, and then we are putting the load balancer in front. We're pre-configuring all the firewalls for you. So after 10 minutes or so, it should be ready to go. So basically, at this point, it was a couple of clicks. When you come here, you'll probably go grab some coffee or tea, and you come back after 10 minutes. Everything should be up and running. Now, the last step is that, by the way, everything that I did was at the org level. So Cloud Firewall Plus operates at the organization level. Here's the part that I come and attach it to individual projects. Basically, I come to a specific project and I say, well, go to this VPC. Now, if you go to this VPC, you will see a new tab that didn't exist before. So firewalls, and also firewall endpoints. So here in the firewalls, I'm going to say add a firewall rule here. So add a firewall rule here basically adds the firewall endpoint that we just created to your VPC. So everything is configured right now. We created our security profile, which declares our intention, what to block, what to alert on. We create a group for that. We created the actual firewall endpoint. And lastly, we are attaching it to the VPC at the project level. And here's the end result. So you can basically, inside the Firewall Manager, you are not leaving Google Cloud Console. Inside the Firewall Manager, you can see all of the security stuff that are happening in your environment, all of the alerts, all of the incidents, all of the exploits that were trying to be run in your environment. And you can see that some of them were blocked, some of them were just logged, and you can click on individual ones and get like more information in terms of which CVE it is, and then basically what are the IP addresses. You can look at the details logs, or you can go to Cloud Logging or Security Command Center or Chronicle, because we have out-of-the-box integration with those as well, and extract more information. So that's pretty much what I wanted to cover on Google Cloud Security. We talked a lot about the importance of threat detection and threat hunting and preventing command and control channels and lateral movements and exfiltration of data. I hope I presented enough tools for you to basically go back and reevaluate your environment and take a look at the new technologies that exist now for adding more security into your environment and having a better security posture. Okay, so I think we have a few questions in the chat window. Let's take a quick look. First one, I can take an attempt at it, and then Dave, Martin, please feel free to add if you want to. Collaboration between security team is essential. How do we basically, how can telemetry data be shared and utilized across all of those? Absolutely. That's a real problem that needs to be solved. You have different teams. You have the dev teams, you have the application teams, you have the DevSecOps teams, you have the SecOps teams. All of them might be using different tools. I think there are two key aspects here. First of all are the organizational policies. So you have to have consistent data governance and organization policies across the board, regardless of which project they are using. Everything should fall under the same policies. Number two is consolidation. Basically, try to use the tools that operate as a consolidated version of your SIEM, your threat detection platform, and your endpoint platform. Chronicle, for example, which is the Google's first-party services, is one of those platforms. There are some other third-party solutions as well. We are very welcoming and open to our partners. We have a great partner ecosystem. We are very proud of them. They enrich our solutions wherever we have a gap. But basically, I think two aspects to this question: consistent organizational policies, and also consolidation of your SIEM and threat detection and threat hunting platforms, and basically leveraging everything centrally in your SecOps environments. Dave, Martin, do you guys want to add anything to this question?
Yeah, I mean, just to just add on to what you said, with data, it's easier to collaborate or have a more cohesive posture when, there's a centralized platform where all of your data is. So like whether your security team needs specific data, whether your development team or DevOps teams need specific data, having that data in sort of the same platform, and then creating like different policies to who has access to what data, and stuff like that could definitely help. And with Datadog, you're able to like shed all of that data into a single platform, and control access to that data based off of whatever teams you might have in regards to what they might need that data for, and what specific data they can access within the platform. So just adding on to what Kambiz already said.
Wonderful. The second question is actually Cloud Firewall Plus related. I'll take that. So what's the overhead of TLS decryption? Great question. So it's really hard to answer this question because it depends on your mixture of traffic, what are your payload sizes. So there's really not a uniform answer that I can give you. If I just want to give you a ballpark number with the base test that we have done, think about losing between 40 to 50% of your throughput. So let's say if your Cloud Firewall Plus operates at 10 gigabit per second for the traffic that is fully clear text. Now, if you are enabling TLS decryption, think about for all of your traffic, think about losing almost half of your throughput. But again, this really much depends on your traffic mix and your payload sizes. Next question is also Cloud Firewall Plus. We have a lot of questions on that. That's great. It's easy to create it in the console. We have Terraform or deployment manager models of it. Yes, we will have. Next question, what is the pricing model? Good news, it's free. It's in public preview right now. And until we go GA, it's free. Go ahead and use it right now. Most likely, so we will announce the pricing model, but most likely it's going to be per endpoint and per hour model, if it's similar to Cloud IDS. So basically, you're going to be charged, just to give you a ballpark number, let's say $4 per hour for basically creating those endpoints. And also, you will be charged for the amount of traffic that you are passing through it. So it's a pay-as-you-go model technically. Does the usage of Firewall Plus introduce any latency in packet transmission? Few milliseconds. All we are doing is really we are hijacking it, inspecting it, and bring it back. So probably a 1 or 2 millisecond for the actual transmission of the packet, and then a few milliseconds inside the firewall. So for most applications, it should be within the latency budget of the application. Last question is for you guys, Martin and Dave.
Oh, cool. I can take that one. So Datadog has a cloud security platform. We have multiple multiple products in there to help customers secure their cloud environments. One of those is a cloud SIM, which ingests telemetry data, usually logs. For specifically, let's talk about Google Cloud. It'll ingest your Google Cloud logs and will perform analytics on top of that to surface any threats to your environment. And then in addition, this kind of feeds into Kambiza's point about consolidating your security platforms together. So we also have a cloud security posture management product, which aids our customers in ensuring that their cloud platforms are secure, there's no misconfigurations, and that they're aligned to any compliance frameworks that they're required to align to. And we also have a cloud workload protection product, which looks at logs or telemetry data that comes from containers. Workloads in the cloud tend to be relatively complex, so this helps detect any threats there. And lastly, we have an application security management product, which pairs with our APM, application performance management. I think I'm getting that acronym correct, hopefully, which is very cool. And for most customers who are running applications in the cloud, a sort of marriage of these multiple cloud products helps our customers detect threats, which Day and I enjoy doing. Don't know if you have anything to add, Day, other than that, I think I may have answered it.
Yeah, that's about it.
I think we may have some more Cloud Firewall Plus questions there, Kambiz, I believe.
Looks like you're on mute, Kambiz.
Yes, sir. Thank you. So if you want to implement this, what do I need to do? I assume that's related to the Cloud Firewall Plus. So the public documentation is actually available. Just search for Cloud Firewall Plus and you will see the implementation details. I showed you a couple of slides in terms of how to deploy it, but basically you will have the full documentation. How easy it is to integrate Cloud Firewall Plus with incident management services such as ServiceNow. So we will basically add plugins that will enable those types of integrations. As I said before, when it comes to be GA, we will publish some of those plugins. So we imagine we will have an ecosystem of plugins that we will add to Cloud Firewall Plus. Great question, by the way.
Well, all right. I just wanted to step in and I'll go through a couple of my closing remarks, but if we do have any more questions come in, we'll be sure to tackle it before we close things out. So for our audience, just a reminder that we have been recording our conversation today. Following this program, you will receive an email with a link to access that recording for you to view on demand whenever you'd like. You can also find it on the DevOps website at devops.com/webinars, and it will be in the on-demand section. Additionally, we will be selecting 2 people to win a $50 Amazon gift card, and we'll be pulling from those who fill out our survey, sent in questions, sent in chats. So if you notice at the top of the chat, you'll see a link to our survey. Feel free to click on that and let us know your thoughts before you close things out today. All right, gang, did we see any more questions come in or are we good to go?
Looks like we have no more new questions.
Yeah.
Well, awesome. Day, Martin, Kambiz, thank you all so much for joining us on Techstrong Learning. It's such an honor to learn from you today and to have you fill up our entire hour of good, wholesome content. So thank you all so much for joining us today.
Thanks for having us.
Cool. Yeah, thank you.
Thank you very much.
Of course. And I'd also like to thank Datadog for sponsoring our program today. And to everyone still here, thank you so much for joining us. We hope to see you at a future Techstrong Learning Experience. Have a great rest of your day, and you may now disconnect, everyone. Thanks again.